everybody. I'll be starting soon. I'm just gonna test the audio. Please let me know if you can hear me well. Okay, welcome. Parth, can you hear me well? Do let me know, please. So we are ready to start, I believe. Everything is in order. Here we go. Welcome to fine-tuning. Again, like I said, please let me know if there's an issue with the audio. So this was just announced like half an hour ago. I saw it on Twitter, or X now. We're gonna read through it. We're gonna look at the blog post, the fine-tuning documentation, pricing, and I also have made a video on this earlier, many months ago, on fine-tuning GPT. You can actually find that at www.ecohive.live. Link is in the description as well. This showcases how you can fine-tune an earlier GPT, DaVinci, and Curie models, but it's not so different. We're going to talk about all that, but let's just take a look. GPT 3.5 Turbo fine-tuning and API updates. Developers can now bring their own data to customize 3.5 Turbo for their use cases. What does this mean? Well, let's read on. Fine-tuning, let me zoom in. Fine-tuning GPT 3.5 Turbo is now available with fine-tuning for GPT-4 coming this fall. Also, this is only available for GPT 3.5 Turbo and not for 16K. But for fine-tuning 16K and GPT-4 is coming towards the end of this year. These updates give developers the ability to customize models that perform better for their use cases and run these custom models at scale. Early tests have shown a fine-tuned version of GPT 3.5 Turbo can match or even outperform base GPT-4 level capabilities on certain narrow tasks. As with all our APIs, data sent in and out of the fine-tuning API is owned by customers, not used by OpenAI to train other models. Fine-tuning use cases. Since the release of GPT 3.5 Turbo, developers and businesses have asked for the ability to customize the model, right? Developers can now run supervised fine-tuning to make this model perform better for their use cases. So this is different than giving it examples. This is different than retrieval augmented generation, such as from a vector database. You are essentially changing the weights of the model itself. You are retraining it. In a sense. So this is way more fundamental than any other method like prompting and other methods like giving examples or retrieving examples from vector DB, which is retrieval augmented generation. In our private beta, fine-tuning customers have been able to meaningfully improve model performance across common use cases such as improved steerability. Fine-tuning allows businesses to make the model follow instructions better. So what happens is, before we continue, I'll just quickly show you what you're going to be doing to be able to fine-tune a model is that you're going to be creating a data set that looks like this. You're going to have a messages list, which is encapsulated in a dictionary or a JSON object. And you just have your examples. See, here's a system role. Okay, so pay attention that the system role is the same, because you probably want to generate multiple examples for a particular use case. In this case, the use case is a factual chatbot that is also very sarcastic. And then you give it examples here. The user is asking, what is the capital of France, who wrote Romeo and Juliet, how far is the moon from Earth, and then you also give it the kind of assistant response that you're looking for. Paris, as if everyone doesn't know that already, just some guy, William Shakespeare. So you give the examples of what you are looking for, in this case, like sarcastic examples. So you would have a bunch of these. OpenAI recommends having 50 to 100 examples such as these to begin with, and see if the model improves. They say that 50 is a good starting point and shows improvement even at 50. And if you see improvement at 50, then they say, then this is the time to increase your data set. So improved steerability, why? Because you no longer have to write really long prompts. If you fine-tune a model with these examples, then the model understands what you're going for. So you can reduce the size of your system prompt, system message, along with you no longer have to give so many examples. Reliable output formatting, fine-tuning improves the model's ability to consistently format responses, a crucial aspect for applications demanding a specific response format, such as code completion or composing API calls. A developer can use fine-tuning to more reliably convert user prompts into high-quality JSON snippets that can be used with their own systems. Because whatever the examples you give here is going to be fine-tuning the model. So the sky is the limit here. Whatever kind of output you like, you can craft the assistant messages to fit that criteria. Again, this will allow you to free up the system message and save your own tokens. Custom tone fine-tuning is a great way to hone the qualitative feel of the model output, such as its tone, as we see here in this example. With the examples, we're trying to get the model to respond more sarcastically. In addition to increased performance, fine-tuning also enables businesses to shorten their prompts while ensuring similar performance. Fine-tuning with GPT 3.5 Turbo can also handle 4K tokens, double our previously fine-tuned models. Well, that's talking about really earlier models, right? Because we have 8K GPT-4 and 16K 3.5. Early testers have reduced prompt size by up to 90% by fine-tuning instructions into the model itself, speeding up each API call and cutting costs. The reason this happens, again, is that if your use case is very complex and requires really in-depth instructions in the system message, and including a few short examples, now your system message or your conversation is going to just grow. You're going to have quite a list of instructions dealing with each edge cases maybe, and you're going to give the model some examples, maybe 1, 2, 3, 5, whatever makes it working accurately. But instead of having to inject it into each API call, you'll be able to fine-tune the model once with all those examples and all those instructions. This is why when they mention that prompt sizes can be reduced up to 90%, because you no longer have to include the entire instructions plus the example set into each API call. Fine-tuning is most powerful when combined with other techniques such as prompt engineering, information retrieval, and function calling. Now, function calling in the first iteration of fine-tuning is not possible. We do not currently support function calling examples, but are working to enable this. This will probably become available at the end of this year, just as fine-tuning 16K and GPT-4 will. So keep that in mind. But this doesn't negate the fact that you can still do information retrieval. You can still do prompt engineering on top of the tuned model. Remember that fine-tuning a model is actually essentially changing that model for your use case. So the weights of the model, underlying model, is changing. I'll try to give you an example of what I mean. If I go to my playground, I have fine-tuned many models before in the completion endpoint. For those of you who remember the completion endpoint, you could have selected from DaVinci, Curie, Babbage, and Ada models, but any fine-tuned model will show up right under here where it says fine-tune. So as you can see, I have quite a lot. And to be able to call these models, if I were to select it and view the code, where you would type in for example, GPT 3.5 Turbo, you would actually type in the name of your fine-tuned model. And that's how you've been making the calls to. Important thing here is that, as you see, you're calling a totally different model because this model now is essentially and fundamentally different than the base model. This is how it's going to work. I don't have any examples for the 3.5 yet because this just got announced half an hour ago, but I will be making a video on that. So continuing, you can still use prompt engineering, information retrieval, but with your fine-tuning examples, you are essentially crafting the model to your use case. Fine-tuning for 3.5 16K, along with function calling, and GPT 3.5 will be coming later this fall in a few months' time. Fine-tuning steps is like this. You prepare your data. Each one of your data or rows is going to be in this format. This is right because chat completion's data formatting schema is different than the earlier prompt completion pairs. We know that we now have a messages list. But pay attention that each one of the messages list is encapsulated in an object, JSON object or dictionary-like format. Pay attention to the curly brackets. So your data set is going to be consistent of this. Whatever system message you're choosing and whatever user assistant interactions you see fit for your use case. If we again go back to the example in the fine-tuning documentation, as we see the system message is always the same, but there's many user assistant examples, user assistant interaction examples. Here there's only 3 examples, but OpenAI recommends to start with 50. So truly fine-tune a model, then OpenAI recommends to have 50 of these messages lists with the system message that you're working with and the user assistant interactions that you're looking for. Okay, then you're going to upload those files. Fine-tuning takes place with CLI, command line interface. This example is curl, but there should be other examples here, such as you can instantiate it within Python like this. Okay, we'll take a look at these here in a moment. So don't let that get in the way. You don't have to use curl. And then you create a fine-tuning job, point it to your data set which you have created. I believe you save this as a JSON file. And after that point, you just make a regular API call. You just use the fine-tuned model that you have created. That's it. And you give it the same system message and you give it the user query, and then you will now get the fine-tuned model to respond to you. It says here that we will also be debuting a fine-tuned UI in the near future, which will give developer easier access to information about ongoing fine-tuning jobs, completed model snapshots, and more, because this was a bit difficult earlier because you initiate the fine-tuning from the command line interface, or whether you initiate it from the command line interface or from your Python. It was a bit difficult to see the progress on that. You'd have to continuously query to see where the fine-tuning process is at. So what OpenAI is promising is that they're going to have some user interface to be able to see all that. Pricing, yes. So pricing is pretty hefty, but we have to keep in mind that the idea, so you get 2 benefits with fine-tuning, okay? Number one, you get a much more usable model for your use case. So idea is that you should be willing to pay more for that, because both the API calls, both the input and output API calls is going to be more expensive for fine-tuned models. And fine-tuning itself costs money. Let's take a look what I mean. Here is GPT 3.5 Turbo's costs, right? We are only looking at the 4K context because fine-tuning is only available for 4K currently. So if you look at here, so this is the 4K API cost for input and output tokens. So here is fine-tuning cost. This is the training cost. This is the input cost. And this is the output cost per 1,000 tokens. So while you're fine-tuning, you're spending about 1/10 of 8 cents for every 1,000 tokens. This is about, what is it, 4 or 5 times, approximately 5 times as much as how much it costs for your input tokens when you're making the API call. But after you fine-tune your model, that will be available for you in the future indefinitely. So this is a one-time process while you're fine-tuning. After that point, you will be making your calls to the fine-tuned model, not the base model, and you will be incurring charges such as these. If you look, your input tokens will be 12 cents, 1.2 cents for 1K tokens, which is approximately 9 times as much as the base model. And the output will be 6 times as expensive in comparison to the base model. So it's quite a bit of a cost difference. And you might not see it justified even if you reduce your prompt 60 to 90%. But considering the quality of the output is going to be improved, so it's just a simple math. You'll just have to try, fine-tune, and see if this cost difference is appropriate for your use case. Okay? So now let's take a look at the documentation. Let's see what it says. So you're essentially customizing a model for your application. Fine-tuning essentially and fundamentally changes the model's weights that underlies that model. So you completely change the base model to deal with your use case. What fine-tuning lets you accomplish is higher quality results than prompting, ability to train on more examples that can fit in a prompt. Because I believe, as far as from my experience, there is no limit to how much data you can retrain or fine-tune the model on. Token savings due to shorter prompts, because after the model has been trained on, you no longer have to maybe include as much instructions or examples to the model. Token and lower latency results. Apparently, this makes it faster. I did not know this fact, but apparently, if you're using more tokens per API call, your latency goes up, or that maybe fine-tuned models have a lower latency. GPT-3 models have been pre-trained on a vast amount of text. To use the models effectively, we include instructions and sometimes several examples in a prompt. Using demonstrations to show how to perform a task is often called few-shot learning. Fine-tuning improves on few-shot learning by training on many more examples than can fit in the prompt, letting you achieve better results on a wide number of tasks. Once a model has been fine-tuned, you won't need to provide as many examples in a prompt. This saves costs and enables lower latency requests. At a high level, fine-tuning involves the following steps. Prepare and upload training data, train a new fine-tuned model, use your fine-tuned model. And if we've looked at the pricing, right? It costs to fine-tune a model. It's about 7 times as expensive for input tokens and 6 times more expensive for output tokens to make API calls to your fine-tuned model. What models can be fine-tuned? We are working on enabling fine-tuning for GPT-4 and expect this feature later this year. So you can only fine-tune the 4K GPT 3.5 turbo model. The fine-tuning for 16K and GPT-4 is going to come later this year. Also, function calling is not available. Function calling is not possible with fine-tuning. Okay, when to use fine-tuning. Fine-tuning GPT models can make them better for specific applications, but it requires a careful investment of time and effort. We recommend first attempting to get good results with prompt engineering, prompt chaining, which is breaking complex tasks into multiple prompts, and function calling, with the key reasons being there are many tasks for which our models may initially appear to not perform well at, but with better prompting, we can achieve a much better result and potentially not need fine-tuning. Iterating over prompts and other tactics has a much faster feedback loop than iterating with fine-tuning, which requires creating datasets and running training jobs. In cases where fine-tuning is still necessary, initial prompt engineering work is not wasted. we typically see best results when using a good prompt in the fine-tuning data or combining prompt chaining tool use with fine-tuning. So what they're saying is, don't go to fine-tuning right away. Do all the due diligence and efforts of trying to get GPT to do your specific application with prompt engineering, few shot examples, chain of thought prompting, and all that. Also with function calling. Try to get the best output with all the traditional methods. And only after that, then go to fine-tuning. And they say that your efforts in this will not be wasted because your data set will include all the elements that you have found to be working best for your use case. Our GPT Best Practices Guide provides a background on some of the most effective strategies and tactics for getting better performance without fine-tuning. So yeah, there's a link here. I'll actually put it in the chat. There's a guide on strategies to prompting, few-shotting GPT, okay? For about other common use cases for fine-tuning, some common use cases where fine-tuning can improve results are setting the style, tone, format, and other qualitative aspects, as we have seen earlier in the examples. We haven't gotten there, but we were looking at it. See, in this example dataset just made up of 3, we were trying to set the tone to responding with sarcastic format, but factual but sarcastic. So number 1 is setting the style, tone, format, or other qualitative aspects, improving reliability at producing a desired output, correcting failures to follow complex prompts, handling many edge cases in specific ways, performing a new skill or task that is hard to articulate in a prompt. What does this mean? Like, you can give it many examples in your data set rather than trying to come up with a really ingenious way to create an instruction in a prompt. So examples are, fine-tuning is all about examples. So you'll be able to generate examples which you can then use to fine-tune a model. I will point out to a really interesting repo, which LLM trainer. So you might find this useful because this gentleman created a repo which created a collab which trains Llama 2, but with automatically GPT-4 generated data set. So I'll put this. I was thinking of making a video on this, but for those of you who are here, you can click on the link in the chat and go there. What this does is actually it uses GPT-4 to generate a bunch of data, as many as you like, here in this case 100, and then automatically fine-tune a Llama 2 model based on that data set. So why am I mentioning this? Well, because you might use something like this as a template to generate examples to be able to fine-tune 3.5 Turbo. Okay. One high-level way to think about these cases is when it's easier to show, not tell. In the sections to come, we will explore how to set up data for fine-tuning and various examples where fine-tuning improves the performance over the baseline model. Another scenario where fine-tuning is effective is in reducing costs and/or latency. By replacing GPT-4 or by utilizing shorter prompts without sacrificing quality, if you can achieve good results with GPT-4, you can often reach similar quality with a fine-tuned GPT 3.5 Turbo, modeled by fine-tuning on the GPT-4 completions, possibly with a shortened GPT-4 completions, possibly with a shortened instruction prompt. So you can use GPT-4 to generate a data set if you so wish, because you could definitely try that, and this repository allows you to do that. At the same time, if you take a look at this repository, you might give it a shot to fine-tune a Llama 2 model as well. The important thing here is that, I forgot to mention, so I said, well, using a fine-tuned model is going to cost you extra, but where are the savings? So the savings come in because you're able to reduce your initial prompt size. because you no longer have to provide extra examples to the model with each API call. Because now you have fine-tuned the model. The fine-tuned model understands your use case, so you no longer have to provide examples. The second reduction. It comes with you probably then no longer need to use GPT-4 for your use case. Even though GPT 3.5 is more expensive, using a fine-tuned GPT 3.5 is more expensive. It's still cheaper than GPT-4. And also you gain latency in terms of latency because GPT-4 is slow and we know GPT 3.5 is very fast. Okay, so it's going to be up to you what works for you, but these are the things. As you can see, even in input and output usage of fine-tuned model API calls is cheaper than input and output of 8K GPT-4. So let's talk about how to prepare your dataset for a fine-tuning job. Once you have determined that fine-tuning is the right solution, this is to say, after you've done all your prompt engineering and figured out how to get, let's say, GPT-4 to work very well, right? You have optimized your prompts as far as it can take you and identify problems that the model still has. You'll need to prepare data for training the model. You should create a diverse set of demonstration conversations that are similar to the conversation you will ask the model to respond to at inference time in production when you're making API calls. Each example in the data set should be a conversation in the same format as our chat completions, such as this. We looked at it, but we're going to look at it again. Specifically, a list of messages where each message has a role content, and optional name. Oh, I didn't know that. You can have an optional name. Okay, let's not get the situation confused. At least some of the training examples should directly target cases where the prompted model is not behaving as desired, and the provided assistant messages in the data should be ideal responses you want the model to provide. What does this mean? In the example below, we are trying the example that OpenAI provided. Response is a bot that responds factually but sarcastically. Maybe you try to craft a prompt that does this, but maybe in certain edge cases this fails. So what they're saying is that provide a diverse data set of all examples that you can think of, but also focus on the areas where your prompt was failing, right? Where the model was not generating the desired response. So emulate or simulate what the user says for a failed case, and then provide the assistance response as you had envisioned how the model should respond. So the data set for a fine-tuning job is like this. Each row is going to be like a dictionary with the key being the messages, and the rest of it is a list of conversations as you normally would do, the system role, and an example user assistant interactions. So it's actually pretty easy. So these are the examples which you are going to be crafting your data set from. Again, fine-tuning for 16K GPT-4 and with function calling is not available. Later this year, it will be. The conversational chat format is required for fine-tune. The earlier fine-tune jobs, which I have done, and I was showing here in this video, was using the earlier format. You can actually watch this video. The link is in the description. It might give you a better idea. We were following this schema earlier to be able to fine-tune text-DaVinci, right? You prompt and completion pairs, which is very similar to what we're going to do with chat completions, except we just need a list of system, role, and assistant responses. All right. Crafting prompts. We generally recommend taking this set of instructions and prompts that you found work best for the model prior to fine-tuning. So they say do your job at prompt engineering and find the one that worked best, and including them in every training example. So find a set of instructions and prompts and include them in every training example within the system message, this content. This should let you reach the best and most general results, especially if you have relatively few, under 100 training examples. If you would like to shorten the instructions or prompts that are repeated in every example to save costs, keep in mind that the model will likely behave as if those instructions were included. And it may be hard to get the model to ignore those baked-in instructions at inference time that are repeated. Behave as if those instructions, not sure what this exactly means. It may take more training examples to arrive at good results, as the model has to learn entirely through demonstration and without guided instructions. So they're saying, well, maybe you want to remove some of the instructions to shorten your prompt because maybe your instruction system message has 2,000-3,000 tokens. Anyway, but the key here is to provide as many examples as you can. Example count recommendations. To fine-tune a model, you are required to provide at least 10 examples. So that's even 10 is a minimum to be able to start a fine-tuning job. We typically see clear improvements from fine-tuning on 50 to 100 training examples with GPT 3.5 Turbo. But the right number varies greatly based on the exact use case. We recommend starting with a 50 well-crafted demonstrations and seeing if the model shows signs of improvement after fine-tuning. In some cases, that may be sufficient, but even if the model is not yet production quality, clear improvement are a good sign that providing more data will continue to improve the model. No improvement suggests that you may need to rethink how to set up the task for the model or restructure the data before scaling beyond the limited example set. What they're saying is, first do the best prompt engineering job that you can and come up with your best instructions, right, for the model. Then create 50 well-crafted demonstrations based on those instructions that you wish the model would respond in the style of. 50 well-crafted system, user, and assistant interactions, right? The system message will remain the same. 50 user assistant examples, which are well-crafted demonstrations. Then they say, now fine-tune the model for 50 on 50 examples, a data set which consists of 50 examples, and see if the model has improved. And they say that you might need to fine-tune further, maybe with 500 examples, maybe 1,000 examples, but at least see some improvement and make sure that your demonstrations work. If no improvement has happened after the fine-tuning job, maybe you need to go back and rethink your demonstrations, your data set. This will save you time and save you money on the token usage. Okay, so this is important. Start with a small number of data set, take a look at the improvements and iterate. Train and test splits, well, this is just like training a neural network, so you will have to do train and test splits, but I believe the fine-tuning allows you to automatically do that, so you don't have to worry about this, I believe. Let's read. After collecting the initial data set, we recommend splitting it into training and test portion. When submitting a fine-tuning job with both training and test files, we will provide statistics on both. During the course of the training, these statistics will be your initial signal of how much the model is improving. Additionally, constructing a test set early on will be useful in making sure you're able to evaluate the model after training by generating samples on the test set. So they're actually asking you to generate a data set. How do you split a training and test set? You basically just split it like 70%, 30%, 80%, 20%. If you're going to create 50 examples, for example, you can just maybe select 10 to be tested on, or create 50 samples for training and 10 for testing. You'll be able to see the model's loss, I believe, or accuracy. Accuracy needs to go up and loss needs to go down. You can see those during the training process if you're following the training job. So you'll have, even during the training, you'll have indicators whether your accuracy is going up and loss is coming down, right? And then after which time you can actually test to see if the real world use cases are working. Token limits. So each training example is limited to 4,096 tokens. This is just the fundamental limit on GPT 3.5 Turbo. Examples longer than this will be truncated to the first 4096 tokens when training, so they will auto truncate. So make sure that your examples are below this limit. So you're going to initiate a fine-tune job, you definitely don't want to include auto truncated data. Make sure you follow this token limitation. To be sure that your entire training example fits this context, consider checking that the total token counts in the message contents are under 4,000. Each file is currently limited to 50 megabytes. So I guess you are limited in your data set so that your data file cannot exceed 50 megabytes, but that's plenty. You can compute token counts using our counting tokens notebook. I'll put this in the chat if you want to take a look at it. All right. Estimate costs. In order to estimate the cost of a fine-tuned job, please refer to the pricing page for the details of the cost per 1,000 tokens. So they're saying, well, take a look at how many tokens you have in your data set and multiply it. Base cost for 1K tokens, number of tokens in the input file, number of epochs trained. Because you can select number of epochs of training, and each epoch goes over your entire data set each time. For a training file with 100,000 tokens trained over 3 epochs, the expected cost would be $2.40. And the pricing page is here. GPT 3.5 Turbo training cost is right here. 1/10 of 8 cents for 1K tokens. So you can use this calculation. Why do they say $2.4 for 100,000 tokens? Because by this calculation, 100,000 tokens will cost you 80 cents, right? 1/10 of 8 cents times 100. But because you're running 3 epochs, you have to multiply that by 3 and you reach $2.40. Check data formatting once you have compiled a data set. And before you create a fine-tuning job, it's important to check the data formatting. To do this, we create a simple Python script. You can use to find potential errors, review token counts, and estimate the cost of a fine-tuning job. Here is an example, I guess. Once you have the data validated, create a simple Python script. I'm not sure where it is at. I don't see any link. But they say that they have one. So data formatting script, maybe once you have the data validated, the file needs to be uploaded in order to be used with a fine-tuning jobs. So you create this file, you upload your JSON-L file to their servers, right? And then you create a fine-tune model. You use OpenAI's fine-tune job create. You use whatever the name of the training file is, that is the name that is on their server, and you choose the model to fine-tune on, and this should start your fine-tune job. It says, after ensuring you have the right amount and structure for the dataset and have uploaded the file, the next step is to create a fine-tuning job. Start your fine-tuning job using the OpenAI SDK. Model is the name of the model you're starting from, the base model, GPT 3.5 Turbo. Again, fine-tuning is not available for 16K, GPT-4, and with function calling examples, and OpenAI promises those are coming later this year. You can also fine-tune Babbage or DaVinci 002. Keep that in mind. You can customize your fine-tuned model's name using the suffix parameter. So you can input a suffix parameter here, and input some additional information, so you'll be able to see your model. If I go back to the playground and looking at my old Curie fine-tune, see this one, for example, says decrypt words, sentence generator. So your fine-tuned model name will include the name that you've specified in the suffix parameter. After you've started a fine-tuning job, it may take some time to complete. Your job may be queued behind other jobs in our system, and training a model can take minutes or hours depending on the model and the dataset size and if you're in a queue or not, right? After the model training is completed, the user who created the fine-tuning job will receive an email confirmation In addition to creating a fine-tuning job, you can also list existing jobs, retrieve the status of a job, or cancel a job. So you can run these commands: fine-tuning job list, fine-tuning job retrieve. You have to know the name of your fine-tuning job. You can cancel a fine-tuning job. You can list up to 10 events from a fine-tuning job, meaning probably what the current state of the fine-tuning is. You can delete a fine-tuned model as well, like that. Okay, using a fine-tuned model. When a job, so this is great, right? You've done all this work, and now this is the fun part. Again, if you want to see an example of it, you can watch this video where I was automatically generating a data set and fine-tuning a query model. Okay, you can just go to www.echohive.live and type in fine-tuning, and this is the video. Also, take a look at this GitHub repository by Matt Schumer, where he even includes a Google Colab, where he uses GPT-4 to generate a data set to be able to fine-tune Llama 2. Okay, it's really interesting stuff. I put this, you can find this link in the chat box down there. Okay, excuse me. Using a fine-tuned model. When a job has succeeded, you will see the fine-tuned model field populated with the name of the model when you retrieve the job details. You may now specify this model as a parameter into the chat completions or legacy completions if you fine-tune the legacy models. So this is what they mean. You're going to make a regular OpenAI chat completion call as per usual, but instead of specifying the model name as GPT 3.5 Turbo or GPT-4, you're going to be entering the name of your fine-tuned model. Your custom suffix, if you added any, would go right here. Again, I'll show you from looking at my previous fine-tuned models. See, they look like this, which is similar to what they'll look like in this current fine-tuning paradigm. And everything else is the same. That's it. It's just, you just call that model. You can start making requests by passing the model name as shown above and in our GPT guide. Analyzing your fine-tuned model. We provide the following training metrics computed over the course of training. You'll be able to see the training loss, training token accuracy, test loss, and the test token accuracy. So if you're following your fine-tuned job, over epochs. If you're initiating it from command line interface, I believe it'll automatically print on the command line interface from what I remember, but you can query your job, such as with this OpenAI fine-tuning job list events, and I believe it'll list the latest 10 events that have happened. For example, maybe you're training for assuming, like, let's say 3,000 steps for 3 epochs, it'll show you what epoch it's at and how many steps was performed. On top of it, you'll be able to see your training loss. Loss has to go down and accuracy needs to go up for a model to be improving. Because you'll be providing a training and test set, you'll be able to see both. I believe training will take place over an entire epoch before the test set is tested. These statistics are meant to provide a sanity check that training went smoothly, loss should decrease, token accuracy should increase. However, we think that evaluating samples from the fine-tuned model provides the most relevant sense of model quality. We recommend generating samples from both the base model and the fine-tuned model on a test set and comparing the samples side by side. So obviously the best criteria you'll have to see if this really worked for you or not is to generate some examples using both the base model and your fine-tuned model and see how they compare. The test set should ideally include the full distribution of inputs that you might send to the model for inference if manual evaluation is too time consuming, considering using our eval library for how to use GPT-4 to perform evaluations. I'm still yet to look at this eval library in a deep way, but OpenAI provides this, and this is a library, is a framework for evaluating large language model and large language model systems and open source registry for benchmarks. I'll put this in the chat box. Take a look at it if you're interested. That's what they recommend to automatically be able to evaluate model performance, including to evaluate fine-tuned models. Iterating on data quality. If the results from a fine-tuning job are not as good as you expected, consider the following ways to adjust the training data set. Collect examples to target remaining issues. Right? Let's say you crafted this 50 or 100 examples for your data set in the format, right, that is specified right here. And you thought maybe you're good. Maybe you thought you covered all the cases, whatever, but then after you test your model, you realize that this fine-tuned model is not performing in certain cases. Then it says, collect those examples, and it says if the model still isn't good at certain aspects, add training examples that directly show the model how to do these aspects correctly. So expand on your data set. Add it into your data set and then reinitiate the fine-tuning, I believe from scratch. As far as I know, you cannot continue fine-tuning jobs, but we'll read on. Scrutinize existing examples for issues. If your model has grammar, logic, or style issues, check if your data has any of the same issues. For instance, if the model now says, I will schedule this meeting for you, when it shouldn't, see if existing examples teach the model to say it can do new things that it can't do. See if the existing examples teach the model to say it can do new things that it can't do. So it says, make sure your data set is correctly generated. Make sure that you don't have example completions which are not what you wanted model to produce, essentially. Consider the balance and diversity of data. If 60% of the assistant responses in the data says, I cannot answer this, but at inference time, only 5% of the responses should say that, you will likely get an overabundance of refusals. So, right, if this makes sense, make sure, think of your use case and think of the variety of responses that might be generated from your use case and include them in the proportion that you're expecting the model to generate it, right? Don't be biased one way or another. Make sure your training examples contain all of the information needed for the response. If you want the model to complement a user based on their personal traits, and a training example includes assistant complements for traits not found in the preceding conversation, the model may learn to hallucinate information. Make sure your training examples contain all of the information needed for a response. If you want the model to complement the user based on their personal traits, and a training example includes assistant complements for traits not found in the preceding conversation. So you're saying that, I guess what I understand from this is maybe you've specified some traits in all the examples you've given, but you also included complements for traits that doesn't exist in your data set. Then what they're saying is the model then learned to hallucinate information because complements are found in the data set for traits that are not found in the data set. So I guess this is important. Look at the agreement consistency in the training examples. If multiple people created the training data, it is likely that the model performance will be limited by the level of agreement / consistency between people. For instance, in a text extraction task, if people only agreed on 70% of the extracted snippets, the model would likely not be able to do better than this. So it's all very dependent on the quality of the data that you're generating. Make sure all of your training examples are in the same format as expected for inference. Iterating on data quality. Once you're satisfied with the quality and distribution of your examples, you can consider scaling up the number of training examples. Remember earlier, OpenAI was saying, first do all the prompt engineering that you can. Try to solve your problem by using traditional means that are available to you. Use prompt engineering, like chain of thought, few-shot example giving, function calling. And only if you believe that your task is not up to the level as you wish it to be, your API calls, then consider fine-tuning. Then they were saying, but don't fret all this effort that you have done, because it has not gone to waste, because you're going to be using your prompt engineering, which you have developed, to create the data set that you're going to be fine-tuning on. And then they were saying, well, first create a simple short data set, 50 to 100 examples covering most of the use cases equally distributed within this data set, and then see if you're getting improvements based on 50 to 100 examples. Then here is they're going to talk about how to iterate on this and increase the data set. So they're now saying, once you're satisfied with the quality and distribution of the examples, you can consider scaling up the number of training examples, right? After that 50 to 100 examples, you have seen visible and significant increases in quality. Now you can actually consider fine-tuning with more examples. This tends to help the model learn the task better, especially around possible edge cases. We expect a similar amount of improvement every time you double the number of training examples. So this is pretty significant. They are expecting, however, wow, this is good. This is very promising. They say, let's say you have fine-tuned the model with 50 examples and you've seen some amount of improvement. If you double the number, you're going to see that much more improvement for every doubling of your data set. This is awesome. So you can expect, if you go from 50 to 200 examples, you can expect 4x improvement in model performance. You can loosely estimate the expected quality gain from increasing the training data size by fine-tuning on your current data set, fine-tuning on half of your current data set, observing the quality gap between the two. In general, if you have to make a trade-off, a smaller amount of high-quality data is generally more effective than a larger amount of low-quality data. So they've been reiterating the point, right? Even before fine-tuning, like do the best job that you can with prompt engineering, with few-shot examples, with function calling. Even when you move on to fine-tuning, they say, well, take the time to create a high-quality data set. Smaller amount of high-quality data is generally more effective than a larger amount of low-quality data. Iterating on hyperparameters. We allow you to specify the number of epochs to fine-tune a model for. We recommend initially training without specifying the number of epochs, allowing us to pick a default for you based on the dataset size, then adjusting if you observe the following. So epochs are, right, when you're fine-tuning, the base model will be fine-tuned on your example for that many epochs as you specified, or you leave it and OpenAI decides the default based on the size of the data. Let's say if you're fine-tuning on 3 epochs with 100,000 tokens of data, then the model will go over that 100,000 tokens 3 times over, right? This also adds to the cost. That's how you were calculating the cost. 100,000 tokens. Token cost were 1K tokens, right? Times how many epochs you're running. But now they're saying, well, you can specify the number of epochs when, if the model does not follow the training data as much as expected, increase the number by 1 or 2 epochs. This is more common for tasks for which there is a single ideal completion or a small set of ideal completions which are similar. Some examples include classification, entity extraction, or structured parsing. These are often tasks for which you can compute a final accuracy metric against the reference answer. So all that being said, they're saying if you want to try to improve the fine-tuning performance by a way of improving epochs, then they say go slowly, like go 1 or 2 more at a time. If the model becomes less diverse than expected, decrease the number by 1 or 2 epochs. This is more common for tasks for which there are a wide range of possible good completions. So from what I am understanding, and I have had quite a lot of experience training deep neural nets back 5 to 7 years ago, sometimes some of you may know, the more you train the model, the more accurate the results get. But then there's a problem so-called overfitting, because your data set is limited and you keep running the model on that data set again and again and again. The model just really gets to memorize the data set and becomes less generalizable. That's what they're saying. So I guess the same problem can be true here. Increasing the epoch should increase model performance up to a certain point. If you have trained the model on too many epochs, then the generalization of the model might go down. They say this is true, especially if your task included model responses, which covers many diverse type of completions which you were expecting from the model. I hope that makes sense. Fine-tuning examples. Now that we have explored the basics of the fine-tuning API, let's look at going through the fine-tuning lifecycle for a few different use cases. Okay. This one is called style and tone. In this example, we will explore how to build a fine-tuned model which gets the model follow specific style and tone guidance beyond what is possible with prompting alone. To begin, we create a sample set of messages showing what the model should, which in this case is misspelled, should do, which in this case is misspelled words. So we have three examples. So 3 rows of data, so-called, to do what? Marv is a factual chatbot that is also sarcastic. Pay attention that the system message is same. User is asking a question each time, and the response is a factual but sarcastic sounding answer. If you want to follow along and create a fine-tuned model yourself, you will need at least 10 examples. After getting the data that will potentially improve the model, the next step is to check if the data meets all of the formatting requirements. Okay. Oh, right here. Yeah, we had taken a look at that already. Now that we have the data formatted and validated, the final training step is to kick off a job to create the fine-tuned model. You can do this via the OpenAI command line interface or one of our SDKs as shown below. You can do both. This is how you can do it directly from a Python script. So your data set has to be in a JSON-L. It has to have that extension as the file extension. You simply open it and you say fine-tuned purpose and you send it to OpenAI with openai.file.create. This creates your data training fine-tuning dataset file on their server. Then you say OpenAI fine-tuning job create and fine-tuning file with the model name. So they are not specifying this additional middle step because your file name was the file name that you created here in this case was marv.jsonl, but when you uploaded, your training file name has changed. They probably have somewhere to actually list all the data files that you have uploaded, because you're going to have to use the name of the file as it exists in the server. And then the model name is the base model name. Once the training job is done, you'll be able to use your fine-tuned model, just as we have seen, by just calling it. So you'll need to be able to print the name of your fine-tuned models and your name of your data files that you've uploaded, so that you can actually input them as the model and use the name of the file to fine-tune. But is it perhaps an easier way to do this if you go to your playground? I'm looking at my previous fine-tunes. For completions, all my fine-tunes are listed here. You can simply click it and look at the view code, and you can actually directly copy this. But this is for the old stuff, right? You'll be able to, I'm assuming you'll be able to do the same with chat, because view code, this is, you can use this code snippet right away. There's also Node, curl, and JSON explanations. Here's JavaScript. Here's curl. This is actually really useful, because see here, you can set up your system prompts, add all kinds of different messages, and these will be reflected right here. They just added this recently as well. You weren't able to view the code. So I'm saying two things, okay? Once you fine-tuned your model, you'll probably be able to see it here. Now, if you select it, then you'll be able to see right here how to call it. You can actually copy this entire code in Python and then paste it into your application. And also, I'm saying that you can craft you are a cooking chef, like how to cook, how to bake pizza, like something else. Now, if I view the code, look, my system message is here, my user message is here, my assistant message is here. Keep that in mind. This just makes it easier to iterate on your prompting. Okay, you can experiment in Playground. Again, like I was saying, you should be able to see your fine-tuned models here, along with all your code that you need to use in Python or in JavaScript. Analyzing your fine-tuned model, we provide the following training metrics computed over the course of training. Training loss, training token accuracy, test loss, test local. Oh, we have read that. Sorry. We are actually here. We have looked at the example, style and tone. Now we're moving on to structured output. Another type of use case which works really well with fine-tuning is getting the model to provide structured information, in this case about sports headlines. Let's take a look at how they've done it. See, they have 4 examples here. Oh, 2 examples, I believe. Yeah. Let's see. Role is system. Prompt is given a sports headline. Provide the following fields in a JSON dictionary. Where applicable, player, team, sports and gender is displayed like this, it says, and then it gives it some content like calls granted are be Taylor okay to something, and then the assistant, you give the completion that you're expecting from the assistant in the format that you're expecting, and then it's giving another example with this exact same system message, but this time the user message is different. OSU split down the middle on starting quarterback battle. And then again, the example completion from that particular user input. This way, you're fine-tuning the model to return the exact structure that you're looking for. So for those of you who have tried function calling, you might think, well, function calling fixes this. But you might also have noticed that function calling can fail because the model returns some formatting, which the JSON.load cannot load. So it has some issues. So fine-tuning might just be able to fix that. Keep that in mind, especially if you're building a commercial app or something where having given 1,000 examples and you have this very complicated output format, it should do really well with this type of examples, because all you have to do is just generate examples of the structure. If you want to follow along and create a fine-tuned model yourself, you will at least need 10 examples. We have seen that. Yeah, and just like we said, we do a regular call with the fine-tuned model. Here, the system message is the exact same as in our training job. And user content is Richardson wins 100 meters at the Worlds to cap comeback. And we get the type of response we fine-tuned on. Migration of legacy models, FAQ. Okay, when should I use FAQ might be important. When should I use fine-tuning versus embedding with retrieval? Good question, because I believe a lot of people will have confusion on the difference, right? So the answer is embeddings with retrieval is best suited for cases when you need to have a large database of documents with relevant context and information. So large database. By default, OpenAI's models are trained to be helpful generalist assistants. Fine-tuning can be used to make a model which is narrowly focused and exhibits specific ingrained behavior patterns. Retrieval strategies can be used to make new information available to a model by providing it with relevant context before generating its response. Retrieval strategies are not an alternative to fine-tuning and can, in fact, be complementary to it. So they're saying you still can use, right? You still, once the function calling fine-tuning comes available, you still can use function calling. You still can give examples if you so want it. And you can still do retrieval augmented generation. As a matter of fact, you probably want to do that, because you're fine-tuning the model on the general tone and the structure of the type of outputs that you're going for. But if you wanted to give it additional information, you still can retrieve from a vector database and complement it with it. When can I fine-tune GPT-4 or GPT 3.5 Turbo 16Ks? We plan to release support for those later this year. How do I know if my fine-tuned model is actually better than the base model? We recommend generating samples both from the base model and the fine-tuned model on a test set of chat conversations and comparing the samples side by side, or they say you can automate this by using OpenAI eval framework, which we talked about. Although this looked to me a bit complicated, but take a look. I believe I put it, the link is in the chat box. Can I continue fine-tuning a model that has already been fine-tuned? Now, this is a good question, but no. So you can only fine-tune from scratch every time. So you cannot continue a fine-tuning job. But they plan to add that later. How can I estimate the cost of fine-tuning a model, right? We talked about this. This is the cost of fine-tuning GPT 3.5 Turbo. This is the only model that is available to fine-tune with the 4K context limit. For each 1K of training tokens, you're spending 1/10 of 8 cents. For 100,000 tokens in your training data, you'll be spending 80 cents. And you're spending this for each epoch of training. If you're training for 3 epochs with 100,000 tokens, then you'll be spending $2.4. 100,000 tokens, that is 80 cents. For 3 epochs, 3 times 80, $2.40. That's how you estimate. Does the new fine-tuning endpoint still work with weights and biases for tracking? No, they don't support that. How many fine-tuning jobs can I have running at once? So I guess you just have to look at your rate limit. Fine-tuning. Paid users. If you're a paid user and you've just signed up with OpenAI, you can do 12 fine-tuning jobs per day. You can only have 1 job running per model. Paid users, if you have been with OpenAI for more than 48 hours, it's still the same. So that's it. This is exciting. If you have any questions, please ask. Otherwise, I'll slowly end this live stream. There's a blog post. There's the fine-tuning documentation. And pricing are probably the most important things we talked about. I did mention that you can watch this video where I have fine-tuned old completions model and automatically generated a data set. You might find it interesting. The link is in the description, but here I'll paste it in the chat as well if you want to take a look at that. Best practices and evals. They say to use OpenAI evals to evaluate your models, which makes sense. Take a look at that. And we have talked about Matt Schumer's GPT LLM trainer, in which he has a Google Colab, which automatically generates a data set to be able to fine-tune Llama 2. So this is interesting. I'll put this in the chat as well right now. It's an interesting proposition to be able to fine-tune Llama 2, but you can use some of the ideas presented here to be able to generate data sets to be able to fine-tune GPT 3.5 Turbo. Okay, so that's it. And lastly, I said make good use of your playground. Like I said, if you go to view code, you can craft your system messages, user assistant interactions here, and you get a quick code example here, and your fine-tuned models should show up under models when and if you fine-tune a model. Thank you for joining, and this was really exciting. And See you in the next stream. Take care, everybody.